online class, we got you. Wherever you want to from, we got what you need. Today online class, we got you.
Good day, everyone. Once again, you are welcome to Today online class. Just as I've introduced the set of numbers, so the first set of numbers, the first set of numbers are called the natural numbers. The natural numbers. So denoted, this one is denoted as n, as we have it on the bottom. Good day, viewers all over the world. You are welcome to the online class. Today we want to talk about rectilinear motion. So we want to look at the application of differentiation or differential calculus to rectilinear motion. Of course, we know that rectilinear motion is the motion of a particle on a straight line. When we have motion of a particle on a straight line, it is referred to as rectilinear motion. Then if x is a function of t, then this could be referred to as distance. We call this distance. This could be referred to as distance or displacement. So what is distance? Is the rate of change of speed with time. So is the rate of change of speed with time. And if it is displacement, that will be referred the derivative will be called velocity. And what is velocity? Velocity is the rate of change of displacement with time. So from this displacement, we can go ahead and find v. V will be dx over dt, which is same thing as f prime of t. This is called velocity. That is, when we take the derivative of the displacement, we are going to get velocity. Velocity is the rate of change of displacement with time. Then we can also go ahead. Then before I continue, please you note that if dx dt is equal to 0, that is, if the displacement is equal to 0, the particle is momentarily at rest. That is, when the particle is at rest, is at a point, dx dt, the velocity will be equal to 0. So if the x dt velocity equal to 0, it simply means that the particle is momentarily at rest. So please let's note that. Then we can also go ahead and find what is called acceleration. What is acceleration? Acceleration is the rate of change of velocity with time. That is, if I take the second derivative of displacement, it can be same thing as the square x all over dt squared. So this same thing as f prime prime of t. It is called acceleration. Acceleration. So acceleration is the rate of change of velocity. Is the rate of change of velocity with time. With time. So if particle moves at constant speed, the acceleration is 0. So if particle moves at constant speed, that is, if the v dt is equal to 0, the acceleration there is 0. If particle move at constant speed, the v dt is equal to 0. So we should take note of that. So we can actually apply differential calculus or differentiation to rectilinear motion. So this is the second application that we want to talk about, rectilinear motion. So let's take 2 or 3 examples on this. Let's take example on rectilinear motion. Example. First one says a particle moves along a straight line. A particle moves along a straight line. A particle moves along a straight line so that after 6 seconds, its distance s meter from the starting point 0 is given by s is equal to t cube minus 15t squared plus 63t minus 40. That is what we have. So the question now, find the first one, the distance, find the distance from 0 when the particle is momentarily at rest, is momentarily at rest, is momentarily at rest. Then the second question, find the velocity when the acceleration is zero. So these are the two questions that we want to solve here. A particle moves along a straight line so that after t seconds, its distance s meter from the starting point 0 is given by s is equal to t cubed minus 15t squared plus 63t minus 40. So we have to find the distance from 0 when the particle is momentarily at rest. So when the particle is momentarily at rest, what is the implication? It simply means that the s dt will be equal to 0. Then we should find the velocity when the acceleration is 0. The acceleration will be 0 when the particle moves at a constant speed. So we are going to see the implication now. Solution. So we are given s to be equal to t cubed minus 15t squared plus 63t minus 40. So we want to find the distance. So we find the s dt. That is, we take the first derivative. If we do that, this will be 3t squared minus 2 times 15, 30t plus 63. The derivative of constant is 0. That's what we are going to get. So this is what we have. Then when the particle is momentarily at rest, v is equal to 0. This is v. Rate of change of distance with time, or displacement with time is v. So it simply means that 3t squared minus 30t plus 63 equal to 0. And of course, I can divide through by 3. 3 can divide everything. So that I will have t squared minus 10t plus 21 equal to 0. This is quadratic equation, so we can go ahead and simplify this. I will have t squared minus 7t minus 3t plus 21 equal to 0. Then t is common. T minus 7 minus 3 is common. Then we have t minus 7 equal to 0. Is equal to 0. So from there, we have t minus 3 equal to 0 or t minus 7 equal to 0. So t is equal to 3 or t is equal to 7. So t is equal to 3 or 7. That is t. So there are two values for t. So we want to find the distance. So we know the time now. We know the time when the particle is momentarily at rest. So what will be the distance? A, the first part. When t is equal to 3, what is distance? X will be with t cubed minus 15t squared plus 63t minus 41. So when t is equal to 3, we have 3 cubed minus 15 multiplied by 3 squared plus 63 multiplied by 3 minus 41. Then at the end of the day, we have 27 minus 3 times 3, 9. That's 135. That's minus 135 plus 189 minus 41. So we are going to get 41 meters. So when t is equal to 3, the distance is 41 meters. Then B, when t is equal to 7, the distance S will now be, that will be 7 cubed minus 15 multiplied by 7 squared plus 63 multiplied by 7 minus 41. Then this will give us 343 minus 735 plus 441 minus 41. And at the end of the day, we are going to have 9 meters. So when the particle is momentarily at rest, the distance are 9 meters and 41 meters respectively. So these are the distance when the particle is momentarily at rest. So that is that about the A part of the question. The eighth part of the question. So we have been able to find the distance from zero when the particle is momentarily at rest. Then we go ahead and solve the second part of the question, B, the B part of the question. So we have to find the velocity when the acceleration is zero. So we have gotten the velocity, that's the s dt, as we've gotten that as 3t squared minus 30t plus 63. So what will be the acceleration? Acceleration is the v dt, that is rate of change of velocity with time. Then if you differentiate this, we are going to have 60 minus 30. That's what we have. We are going to get 60 minus 30. That's what we are going to have. Then when we have to find the velocity when the acceleration equal to zero. So 60 minus 30 is equal to 0. 60 is equal to 30. Then t is equal to 30 divided by 6, and that is equal to 5. So t will be equal to velocity. Here we are going to have 75. This is minus 150 plus 63. Then at the end of the day, we are going to get the velocity. Let's check. The velocity is, yes, that will be the velocity. This is 3t squared minus 30 plus 63. Then we have 60 minus 30. So the velocity will now be 50 plus 63. That is 8. 138 minus 150, and that will go to minus 12 meters per second. So the velocity will be minus 12 meters per second. So that is what we are going to get. So that is that about the first example. Let's take one more example. Under the application of differential calculus to rectilinear motion. Example 2. Let's take another example. Example 2. It says that the motion of a particle, along a straight line, the motion of a particle along a straight line is specified by the equation x is equal to 6t cube minus 2t squared. The motion of a particle along a straight line is specified as is specified as 60 cube minus 2t squared, comma, find the velocity and acceleration after 2 seconds. So the motion is specified as 60 cube minus 2t squared. So we want to find the velocity and the acceleration. The velocity will be changing the x over the t, and that will give us 6 times 3, 18t squared minus 2 times 2, 40. That's velocity. When t equal to 0, is equal to 2 after 2 seconds, we are going to have 18 into bracket 2 squared minus 4 into bracket 2. This will give us 72 minus 8, and that's going to be 64 meters per second. So the velocity after 2 seconds will be 64 meters per second. Then that's the first thing. Then the second question is to find the acceleration. Acceleration is rate of change of velocity with time. So that will be the v dt. Then this is going to give us 36t minus 4. That will be 36t minus 4. So after 2 seconds, when t is equal to 2, we are going to have acceleration to be equal to 36 multiplied by 2 minus 4. That will be 72 minus 4, and that's going to give us 68 meters per second square. So the acceleration will be 68 meters per second square. So I would love to stop here because of our time. We are going to continue from there in our next class. Thank you, and God bless you all.